Hi class. In this video, we're going to try to combine some things. First of all, we're going to look at using the online debugger and some of the features that they highlight for you in Chapter 12. At the beginning of Chapter 12, that information is very critical to you as a programmer. It's important that you learn how to use the debugger, how to control its features, and how to let it help you do your job. Now, the second half of Chapter 12 talks about exception processing, and exceptions are unexpected error conditions that hit our programs. Sorry, my voice is going. One type of exception would be non-numeric data in an integer type field. We know now that if we use the try parse statement, we can safely determine if the data inside the string contains an integer. But if we didn't do that try parse and we just convert it directly, we know that we can result in a runtime error, and that's an exception. When we have an exception like that, it is quite disruptive to the operating system. It has to gather all sorts of information for our program and pass it over to whatever debugger manager might be going on, and ask us if we want to save all that. So it creates a lot of dump files. So it is quite a bit of overhead for us to have exceptions and runtime errors in our programs. And more importantly than that, runtime errors are very disruptive to our users' work. So we want to make sure that we do everything we can in our program to intercept those runtime errors. We have a lot of exercises available for you on REPL to really enforce those runtime exception handling items to you. We'll also do a little bit of experimenting with those things in this video. First of all, I'm going to create a new project in Visual Studio. Oops, not a new repository. I'll close that. And I want this to be a console app. And I'm going to name this console app Debug Demo. And I'm going to put something like Chapter 12 on there because that is what we're going to be working on. I'll click OK to create that project. For my project, I'll go ahead and rename my program.cs file. And I'll rename it main class, like REPL likes it, has that. And then we can get things pretty consistent. Now, we've been able to do a lot with REPL, but we can't really emulate the debugger functionality. This is a feature of Visual Studio that you have to have the Visual Studio product for at this time anyways. Now, in my main class, I don't really have anything that I want to do at this point, but what I'm thinking that I want this program to do while we're demonstrating how to use the debugger is I want this program to be somewhat similar to your Project 2 assignment. In your Project 2 assignment, you're supposed to print out several triangle shapes, series of asterisks. And so I'd like to kind of create a program that's similar to that to give you some guidelines and something to go on as you work on creating that triangle program. So I think in our program, we're going to basically create a box shape. So if I think about it, let me bring up just Notepad. Just plain old Notepad will be fine. And what I want to print out is something like a box of characters. So 1, 2, 3, 1, 2, 3, 1, 2, 3. Or I want to be able to have a different symbol printed. So somebody could pass me a $sign and say they want a box that's a size of 4. And then I would do 4 by 4. So you get the idea. This is the kind of output that we'd like from this program. So I want to break it down into objects, into appropriate classes to generate this information, to break up the work and simplify each different function so that each logical piece is contained in its own object. And I see, looking at this, that both of these different shapes are comprised of print lines. So I think that I'll create an object that generates a print line. And so for this object, I'm going to need to know the symbol that's supposed to be printed and the number of times we want the print symbol printed. So pretty simple there. And then to call my print line, I think I want to use a class that is the box, and that'll be my box shape. And in my box shape, I'm going to need to have information about the size of the box. We did 3 and 4 there for our examples. And again, the symbol that is to be used. Is there anything else there that we are going to need to know about that? I'm going to think about it here for a second. I think that should do it. Now I'm going to rearrange these data items because I think that I have them in different orders. And I'd like to keep them in the same order. Now, as we create our code, we might decide that we can access the symbol to be used in our print line from our box class, many different things that we might do to change this a little bit. But I think that then my print line is going to be able to generate this print line based on the information that's passed to it, and it'll just return a string. So maybe we can use that toString method. Our toString method will be public so that we can allow other people to use it. And it'll return a string, and that string value will be that character however many of times we wanted it printed. Okay, so then in our box, the methods that we need are pretty similar, right? We're going to need a toString method. Now our toString method, again, is going to build this output string and pass it to whatever tester thing or program was calling it. I think in our box, because we're going to have a loop in there, we're going to have another method for our toString to call. And we'll call that like build string. And you'll see how that's going to work as we get into it. But basically, it'll keep our toString method simple and to the point, and it'll let our build string method do the processing involved in building that complete string to output this box. So I'm going to minimize this, but this is kind of our UML diagram on the fly. Why am I doing it on the fly? Because I'd like to build it using the Visual Studio capabilities that were presented to us in Chapter 4. And if you remember what those are, first of all, we'll be looking at them. Let's create our new class files. So I've selected our project, and I'm going to right click and choose Add Class. And I want a class that's going to be named PrintLine. That was going to be our first one. And then we also want a class named Box. Of course, we remember in C# our class names always start with an uppercase letter if we're following naming conventions. Now, in my PrintLine class, I could go to that .cs file and start typing my code, and that would be just fine. Let's go ahead and do that because I wanted to look at that class diagram. Let's do that. Look at our class diagram for our PrintLine. There's nothing on there. It just shows us that we have a class. Let's add some more. How can we do that? Add. No. I don't know why it's not letting us add our other class components to it. Let me go back to it. There's our box. I was looking for the old school menu and they've changed it to just let you drag and drop. So I can drag and drop all of our classes out onto this feature here. Now I want to use that class builder, the GUI class builder that we saw earlier. So I'm going to expand that section of my screen a little bit. This is the class details window. If it's not showing up, it can be kind of hard to find, so I hope you're seeing it. Now what I want to put in our class is going to be just our toString method, and I'm not going to create properties and fields because I want to make these static classes, and these are going to be static, meaning that there will only be one instance of them in memory at a time, and so we won't have to create a new instance of our class to use its methods. And I hope you'll see what I mean as we work on this. So we want to create a toString method that is in our class. Now when we are overriding the toString method, we're returning a string. Can we say override, public override in our modifiers? It is public. Now, in our toString, if we're going to do this properly, we need parameters passed to us, because when we're working with a static class, we're not going to have any class level variables because we're not going to have instances of our class out in memory, so we don't have any place to hold those static variables, that makes those class level variables. So we have to do things more in a parameterized manner. So in our toString, we're going to say that we need passed to us a piece of data that's going to be our symbol, and we want it to be a char data type. Then I also want another parameter named num, and it's going to be an integer type, and those are going to be the pieces of data that are passed to our toString method in our println class. Now let's expand this again, and now it shows that toString method showing up, and I want to go to my println.cs file and see if everything is okay. Now I see that my toString method has been generated, but I want to fix it a little bit. First of all, this is going to be an override. And can we override the system toString method and have these? No, we can't have these parameters. So even though we did a great job generating this in our class builder, it's not going to work quite right. So let me think about our design some more. We can't just have our print line use this toString method. We can't override it properly. So instead, let's create our own method called buildString, and it'll return a string value. So I'm going to get rid of the word override, and I'm going to make this named build string. Now I can go back and look at that class diagram if I like, and you can see that it's been updated, that our method name is now showing as build string. If we expand that method, we see that it has two parameters, the symbol and the number of times we want that symbol printed. So let's create that build string method. Now I want this to be a static method, so I'm going to add that modifier here. My method is going to be public. I'm going to let it be called from other classes, but it's going to be static. I'm only going to have one instance of it in memory at a time, and people do not need to create an instance of the println class to use this method. Excuse me. So in our method, we need to set up a string variable. to hold our return value. And our return value is going to be something that we build. So how are we going to build that? Well, we're going to use a loop, and we'll use a for loop, and we'll control our for loop with an integer named I, and we're going to start out with I with a value of 0. So our initialization parameter for our for loop will be allocate a variable named I and set it to a value of 0. Now for our loop control, we're going to run while I is less than or equal to our num variable that was passed to us, because that's our limit variable. And for each time we execute our loop, we're going to update I. We want to add one to that I variable. So we can just take our return value. Oops, we need to give it an initial value. We'll make it equal to a null value, an empty string. Now we can add to that string using the plus equal operator, the shortcut. And of course it does concatenation since we're working with a string. And we're going to add to our return value. And what we want to add is our symbol. So now we've set up a for loop that's going to add our symbol to our return value string as many times as was specified by our number parameter. After our for loop, we're going to return that return value, that string that we have built that specifies those symbols. This is the end of our build string method and the end of our println class, and finally the end of our solution. I'll put namespace, huh? All right, so this program starts out by allocating a string. Can't type. Then we use a for loop. Controlled by I, and it runs NUMB number of times. And in our for loop, we add to just one more symbol. And then we're all done. Now, this is a really simple class. It's called a utility class because it's just going to build this print line for us. I'm going to put some documentation here for this method. And you can see that the XML comments are automatically filled in with some really important information here. My summary is going to say this method builds the output string. And when on my returns, I'm going to say that it returns the output string. Now as the class level, I'll go ahead and create again an XML level comment and say this is a utility class that builds an output line. So my class is done here, my print line class. So I want to show you how I'm going to call this, and I'd like to test it. So we know that we're going to use this in our box class, right? But let's jump straight to our main class and test it out. So I will say that I want to use my print line class, and I want to use the build string method. And in my build string method, now notice here before I type anything, this information that's being generated by IntelliSense, it's picking up all of our common information. It's saying this method builds the output string. It's showing us what parameters we need. So we need a char parameter that's our symbol. I'm going to output some hashtags. And then how big do we want our box? Well, I'll make my box or how long do we want our print line? Because remember, this one's just a print line. I was getting ahead. I want it to be 5. So I will go ahead and set that. Now, when I run this, it's going to generate, the output is a string. So I need to do something with that string. So I'll wrap it in a console.writeLine so that it will output it to the console so that we can test our class and make sure it's working properly. Now I'm going to press Control F5 to run my program and have it pause on the console. And sure enough, we see there we have 1, 2, 3, 4, 5, 6. That isn't quite right, is it? So let's take a look. We need to do some debugging. Now, when I use the debugger, I cannot press Control F5 to run my program. It disables the debugger. So in preparation, I'm going to go ahead and put in console.readKey after my write line so that our console screen will remain open. Now I need to debug here because I've got a little problem and I'm getting 6 £signs output instead of 5, and I specified my parameter that I wanted 5, so it doesn't seem to be working quite right. Now I could just really stare at it for a long time, do some desk checking, step through the code. Those are all great ways to solve problems, but the debugger will help me do all of those things. So I'm going to set a breakpoint here on our console.writeLine statement in our main class. So this is where all the action's happening in our program. To set a breakpoint, you've seen it a few times. If you've watched the videos, you can do a few things. You can come over to this gray area and click, and that red dot indicates that a breakpoint has been set at this line of code. I can also just press F9 when I'm on the line of code that I would have sent the breakpoint on, and I can press F9 again to turn off that breakpoint. Okay, let's leave our breakpoint on and let's start execution of our program. We see the flash of the console screen because the system is preparing this as a console display. And our code is halted here at our console.writeLine statement where we set the breakpoint. And we see that Visual Studio is ready to execute this line of code. It's got it highlighted in yellow. It's got the arrow pointing at it. But I would like to see exactly what happens when this line of code is executed. So I'm going to use the step into control. Now, the first thing that happens is, if I were to look back at that line of code in our main class, which we can, it says I want to do a write line on whatever is output by the build string method of the print line class. So before we do anything else, we're going to call the build string method passing these parameters. So let's go back to that print line class and we can see that happening. So sure enough, we're in our build string method. We're sitting with our yellow arrow pointing at the opening parentheses of that method. So the debugger is prepared to step into this method. Because we are executing our build string method, we have 2 variables that were declared automatically because they're parameters to our method. We had this character variable sim and this integer variable num. So we see the values for those variables down here in our locals screen. Notice that sim displays the code set value for the £sign character, and then it shows us the £sign character converted to a char value, so we see both. Right now, the value of our num parameter is 5. The return value that we're going to be returning is null right now. So let's step into this again and execute. Now we're ready to create our string parameter return value. When we click on the step into, we should see the execution move to the next line of code and that string be allocated in our local screen. So do we see return value? Oh, yep, there it is. It's got an initial value of Nothing, that empty parameter. And I think I clicked step into twice because our for loop has already begun executing. We see the initial parameter being allocated our variable named I, and it's set to a value of 0. So I'm going to step into again, and it'll go to the test section of my for loop. And my for loop test section checks to see if I is less than or equal to that num variable. And if it is, it executes the code inside of our for loop. So we should see one of our symbols get added to our return value. And sure enough, there it is. And notice it's red because it was the last variable that's been updated. Now we have quite a few variables here going on. But I'm going to keep going and step into again. Now my increment or update section of my for loop is going to be executed. We're going to update the value of I. We'll test it again to see if it's still less than or equal to num. It is. So we'll add another instance of our symbol to our return value. So now we've got 2 pound signs. And as we continue, I should be updated to the value of 2. If I keep going through this, I can see the 3rd pound sign get added. And then the 4th. Now, right now, this test, we're testing I with a value of 4. And yes, it is less than or equal our number. And that's correct because we still need one more pound sign to be added to our return value string. So let's step into again. We'll see that value get added. Oh, look, the 5th value got added when I was equal to 4. That's that off by 1 error that they talk about all the time, right? So we were off by 1. So if I continue executing, I'll see that one too many, gets added to our output string. And then that gets returned. If I continue executing in the debugger to see what's going on, the next line of code executed is our read key statement, and we should see the output of our symbols on the screen. Okay, so the debugger was super helpful. I'm going to turn off that breakpoint and go to the print line class. So we saw that we were ending up with 1 too many. So we have a couple of ways we can solve this problem. First of all, we could change the initialization value of I to 1, right? And that would give us 1 less than starting at 0. Or we could change our test condition to say we only want to execute while I is less than num. Well, if I use the less than conditional, that's actually simpler than the less than or equal. So I think that would be the preferred method. So I'm going to change that in that way. Now I should be able to run my program again, and I should see my 5 symbols output. Perfect. So now we know that our print line class and our build string method is working properly. There's another thing we could do with this to change it up just a little bit more. Let's try it. What if I name my build string the same thing as my class name? Can I make it be the constructor? Now it says it can't do that because it's a member name, but what if I get rid of this return string? Remember, constructors don't return a value. It says a static constructor must be parameterless. So it's just causing me all sorts of trouble. So I'm just going to go back and name it back the way I had it. And we'll work with that, creating a static constructor method at another time. And I want you to be thinking about that. How could you do that? How could you set up this class to where when you called it, it automatically ran the constructor and updated some information so that you could have that value back and have it returned to you. That's what we want in this class because it's a utility class. But it's working well the way we have it. We have our class name and we follow that with a dot and then our method name, and that lets us call that method within that class. All right, let's work on our box then, because we've got our print line method working. So let's look at our box class. In our box class, if we return to our notes where we were working on our UML diagram, we see that we were planning on having a couple of, again, parameters, symbol and size. And again, we thought that maybe we could use the toString override, but if we want to do this kind of in the same way that we did our print line class, we won't be able to use that override. So we'll just create it this way. Now we've actually changed things up a little bit because now we have it set as SMB, which is a char, and NUMB, which is an int, and that's a little bit more appropriate for our UML class diagrams. So we'll do the same thing with our box class. Our symbol will be a char, and our size will be an integer. So those won't be class level variables. Those will just be parameters that are passed into our static method. So let's create that static method. We said it's going to need a character that's going to be our symbol and an integer that's going to be our size. And when we are working with our box here, we're going to, again, want to create some sort of string that's the whole box. So I'm going to allocate a string as our return value. And for this example, we're going to again use a for loop. We'll control it with an integer named I, and we'll start I out at, I guess our starting point will be 0 again, and we'll execute while I is less than our size, and we'll increment I each time we execute our loop. So great, we're in good shape. We've started out this for loop, so we should be able to write out our output line. We want to take our output from our print line and add it to our return value. So that means that if we want to be able to add to that return value, we need to give it an initial value. Would be empty, and every time we execute a different increment of I, a different iteration of our for loop, we want to update return value, and what we want to add to return value is one of our print lines. And our print line is going to be whatever symbol they said they wanted, and our size is going to be the size of the line, right? So we're kind of passing that on through to our print line. Now in our print line, I can't just pass those parameters directly. I have to say in our print line class, we want to use the build string method. And then we can return that string back and add it to our return value. Now I need to do one more thing, because every time we add to our return value with a new print line, we want to go to a new line. So let's add that new line character to our return string value. When our for loop is done, we're going to return that return value to our caller, and that should be the completely formatted box. Now in our class, if we add some documentation, we'll say this class generates a printable string containing a box. And then for our method, this method builds a box string, and we'll say in the returns that it returns a box string. Now we got something different to test here. So in our tester, our main class, we want to change it up a little bit, and we don't want to just do a write line on our print line build string. We want to do a write line on our box. Let's run that. And now we should be in pretty good shape, but I'm still getting 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Let's go look at that code. In our box, we're saying that we want to run it starting at I while I is less than our size, and we're ending up with the right number. In our print line, we're saying we want to run it. Oh, I didn't take out that equal sign. How did I do that? I guess I was just a video in here. And those are the kind of errors that can happen. Now I'm going to run it again and see if that corrected that problem. Sure enough, my box is a little oblong on my monitor, but I've got a 5x5 box here that I generated using these classes. Now I know that using class files can be a little confusing, but I want you to really look at these and think about how simple it makes each thing. Now I'm going to add a few more comments here. In our print line class, our return value is going to be a string containing the entire print line, that one print line. And then in our box, if we add some comments to our box class, let's do that. We'll start out again saying that string to return for loop controlled by I runs size number of times, and then call to get a print line, and then add a new line. Oops, I left off a R. And then finally, after our for, return the string containing the entire box shape. Now in our tester, our main class program, notice that it became very simple, and that's what we're striving for. That's what we want, is to make that main class as simple as possible. Now we used the debugger a little bit. We saw that by using the debugger and stepping into our code, we could watch as our code moves from one class and method to another, and that makes it really helpful to use in learning programming, because sometimes it's beneficial to just step through your code to see exactly what's going on. You think that it should be running this 5 times, it's not. This is a great way for you to figure out what's going on. Now when we use the debugger, we do have a couple of other options that we can utilize that are really helpful. I'm going to go to our box class, and I'm going to set a breakpoint on this for loop. And now in our for loop, I want to be able to set up a watch. So I know that by looking at my screen down here, I'm going to see all of those items that are variables in my current program, but I might want to see them in some other situation. So I can add a watch to that. So let's look at our debug. There it finally is. Now I have to actually be in debug mode. If you notice, it's not as easy as some things. And then I can right click and add a watch. And now in my watch window, which is beside my locals window, I have that variable held. Let's go ahead and step through some things. I'll go back to locals and run. And let's see, I'm waiting to see when our variable I gets changed the first time. Now, when we look at our watch, let's see if it's affected by this use of I. And it is not, because it knows that, oh, oops, it is. It doesn't know. I lied. So watch is watching the variable I wherever it may be. Now that's helpful because you can watch certain variables, and you might need to if your locals window is really full, you have a lot going on in your program, and you just want to set up something to keep a watch of. And it's just a quick way to access what the value is of a given variable, because that's what we're using the debugger for. Now we can also set a quick watch. Let's see if we can find that one. This is another type thing, and you can use it to also add watches and reevaluate and do other things however you want to. So look at that section in your textbook, because there's a lot of great information, and you need to kind of walk through it on your own to see how everything works along with everything else. Okay, so far, I'm going to stop here. We've done a lot of great things in this program. We've used classes like we've never used classes before. We've created 2 classes to keep track of our different objects. If we look at our class diagram now, we'll see that each of our 2 objects has that build string method. And in our build string method, if we expand it, we can see what properties or parameters we expect to be passed to us. Now in our main class, we only have that main method, and we don't have any input parameters to our main method. We'll talk about those in our next chapter. Now I can use this class diagram to help me keep track of what I have going on and all those kinds of great things. So let's do one last thing. In our main class, I would like to add a method to prompt the user for the character that they would like to print and for the number of times. So let's create a method here. Because it's in our main class, we'll have to make it static. And this first one is going to return a char value. And we'll call it input symbol. And I'll do a console.writeLine to output my prompt. And then I want to read that in, and I remember that a char data type, is that what's returned from that? Just read. Let's try to be sneaky. Return console.read. It lets me cast it as a char. So we'll see if that works right. Now I want to prompt for that input before I do my call to the build string method. And if I look at my call to the build string method, I really want this symbol to end up right here. So could I just use my input symbol method and call it there? Let's try it. There we go. It's fine with that. So as long as our user gives us a good symbol here, we'll be in good shape. Let's try that same thing with our integer. And it won't let us cast that as an integer because converting from this char data type that we're supposed to get from our read is a simple conversion, but converting to an integer is a little more complex. So we're going to have to actually call the convert class, and we'll convert to int 32. Man, I've been using REPL to type a lot, so Visual Studio is awesome. Now, I'm sure you've noticed on the exams and with our test bank, whenever you have to type in the name of a method, be sure to put a space between the parentheses. I apologize that's that way, but it is that way. So if you're consistent and always do that, then you won't get counted off for that annoying reason. Now, to return back to what we were doing here, we've got this prompt, please enter desired size. We're going to convert it to an integer and return that to our caller. So we can just replace this second parameter value then with whatever gets returned from our input size method. And of course, since it's a method, we need those parameters. I'll put that space, 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 space. It's hard to do, I know. You guys do great. Now, my program should be modified so that I can ask for input from my user. So I'm going to run it, and I want a @. Oops, they got mad at me about something, huh? It says, what are you trying to do? Input size, input symbol, input string. It gave me an exception. It says you have something wrong with your program here. Now, when I am looking at an exception like this, I can do all sorts of different things. I can open the exception settings. I can change conditions of this exception. But basically, I want to see what kind of exception I got. It says to me that the input string was not in a correct format. Well, this is really weird because I was in the method of inputting my symbol when I typed in my char character, and somehow I ended up down here in my read line. So all I can assume is that this dumb read is messing with things again. And I want to fix that right now. I do want to work with exceptions, but not necessarily with this one. So let's fix it. We'll make this read line. And then if we're doing a read line, we can't cast it as a char. So instead, we'll have to use the convert class and say we want to convert to char whatever we read in. Now let's make sure that was really the problem. I'll run this again. And I'll put in my @. Now, that worked better. So that was really causing the problem. Notice that it was kind of weird, wasn't it? It wasn't really noticeable, but that's the kind of thing that happens when we're interacting with the console if we don't make sure that we're getting the entire line and kind of creating a new line situation. So we have to be sure to do that. Okay, for my @signs, I want my box to be 3 by 3. So I'll say that is my size. And then, sure enough, there is my nice box. Okay, so I said we were going to handle exceptions here, and I didn't like that exception that we got. We had to fix it, but that's because it is a little bit of a more of a programming error, almost like a syntax error in that case, where the read method wasn't going to be effective for us. So let's see how we could create an exception in this program pretty easily without that kind of thing, more like a user would do. So if we gave this code to an end user and they ran our program, they can put in whatever symbol they like. Now, what about our desired size? What if they accidentally type a character instead of a number? There's another exception, another format exception. Again, saying that I can't just convert this to an integer because it won't work. All right, well, let's fix it. I'm going to stop running this. And what I'm going to do is, of course, we know that I could put in some logic here to do a try parse, and that would be the preferred method of handling this. You could do a try parse and respond to the user. That size was non-numeric. Please enter a numeric size, and then read that in, and I could trap them in a while loop of that try parse until they gave me some valid data. But there's something else I can use, and that's the try catch block. And the try catch block lets me set things up to catch an error, to keep it from canceling the program at runtime. So when I use a try catch block, I can kind of think of it a lot as like fishing. If I go fishing, which I don't do a lot, because when I'm fishing, I just try and I try and I try and I cast over and over and I keep trying and I just, try to catch a fish. Well, if I ever caught a fish, that would be a catch. And I would do something different finally. I would take that fish off of the line. I would put it on my thingy holding all my fish, that one fish, put it back in the water to take home to eat later because, I can eat fish, one of the things I can eat. So I'd be super happy about that. But basically, this structure that we're going to implement is very much like fishing. We're going to try to do something. And if unusual things occur, like we have an exception, we're going to do something unusual to catch that exception, to process it. So let's see how we put that in the code. We're going to add it to our input size method. And all I'm going to do is add the keyword try. So everything that I want to try is going to be within the opening and closing curly braces of my try statement. So what I want to try is I want to write out this message and I want to try to read in the line from the user and convert it to an int32. And we know it was that converting to the int32 that caused our exception, our runtime error, because it couldn't be properly converted. So I'd like to catch that format error. So I think it was like system, maybe format. Oh, there it is, format exception. Now, whenever I have an exception like that, as I mentioned, the operating system has created a lot of information for me. It's gathered it all up. It's bundled it up for me in an exception package. And in that exception package, I have access to things like the error message that would result from this exception and many other pieces of data. That format exception is a class, and I'm going to call that exception E in my code. So now if I catch an exception, I'm going to do a console.writeLine. And in my console.writeLine, I'm going to say something like invalid data received message equal. And then I'm going to add that exception package message. What did it say? Now, I'd like to continue with my program. So let's see if we can. We'll write another line out that says, please enter desired size. This time, we're going to try to do the same thing. We'll see if we can get this in an end-ending loop, if it'll even let us. How much can we do in our exception block? Now, in both of these states, I'm saying I want to try this, and this catch clause, let's see how this works. Let's make sure we can do it before we talk about it. I'm going to run it, and I'm going to say my desired symbol is $. My desired size is a non-numeric value. Now I get my message, invalid data received, so it's in our catch. It says this message that I got back from the exception is input string was not in a correct format, okay? Please enter desired size. So if we enter a 5, Our program works. Everything's great. We're done. Now, let's try that again. And I'll enter my symbol and a bad input. And now this time I'm going to enter a bad input again. Now we really do have an exception. It's like, I just can't handle this within this again. So we can sort of recover, but we can't recover. We end up having to do that same sort of looping with our try parse. So instead, let's change our program so that it would work properly, and we'll output this message, invalid data received, and we'll say something like size, whoops, I've got to stop running here. Change this message to say something like size set to default of 5. And then we'll return 5. How's that? Let's see what happens. That should work better. Now I'm going to put in my symbol and a bad input, and it says, oh, invalid data received, set to default of 5, and I see my output of 5. So that works great. So that gives me the ability to try to do something, and if I fail, to catch that error so that it doesn't give that evil disruptive exception to my user, and to do some sort of processing at that point. So lots of things we can do there in our try catch. Now the try catch statement has a third parameter, and that's the finally block. And our finally block is something that gets executed either way. So for our finally block, let's see if this is going to work. And we'll output a message like finally have input to the console, and see if we can get to our finally block. Because remember, both of our try and catch are returning the value back to the caller. So we might have to move those returns. Let's see if we have to. I want the symbol $, and I'll put in 4. And I did do my finally have input. And notice that that happened right away. Okay, so it happened before we returned back to our caller, our main. Let's try it again. And this time I'm going to put in a symbol, an invalid input, and we get our invalid input message, then our finally message, and then our output from our main. So in the try catch block, we have an opportunity to try something in our code, catch a specific error, or catch a general error. You'll see more of that when you go through the REPL exercises, which I really encourage you to do. There's just a few of them for this chapter. And then our finally block will execute either way, whether our try is successful or whether our try results in a catch. So we've looked at a lot of information in this video. I hope that you've gathered a lot of data for your brain to contemplate and to think about, and that you can really think about the fact that a class file should be the lowest possible level object, and that way we can really simplify things. You've seen that we can create static classes that just do specific things for us. Why would we not want those methods to just be part of our program? Well, for simplification, because now we've got that logic that belongs with the class, in the class, and we don't have it mixed up with the logic of our tester class, our main class that's trying to generate this information. The more we can separate functionality within our program, the simpler and easier to maintain our code will be. So I hope that that helps you and that you have a lot to think about from these examples. So thanks.